Good afternoon and evening, everyone. This is Terraquator. I'm in VR chat again, as you can see. It is Thursday, February 29th. It's a leap day. It's the leap year, so it's a leap day, 29th. Oddly. Yeah, it's good. It is day 60
I'm
of
sorry,
being
Dave.
sober.
I'm afraid I
I'm
can't
still
do
sober,
that.
I promise. Just because I'm in here doesn't mean I'm drinking. Or, yeah, there we go. I'm not drinking. I'm still sober, so don't worry. I'm in here for a reason, because we're in a spaceship thing. But we're here. We're gonna go to a planetary nebula, so we can talk about why I'm in here. Let's see. Let's go ahead and do that and this. Brighten things up. Wow. Wait. Where are they? Need more neon lights here. That can help with some of the light. And let's see. Definitely not that. There we go. So it's going to be a little bit dim in here, but I'm here to talk to you about... Well, normally I'm here to talk about the fact I'm still sober and the day's going well. It's cold and rainy today. It's like 40 degrees Fahrenheit today and raining. It is very cold. Some of it sounds like it wants to be an icy mix out there. But that is not why we're in the middle of a nebula.
Space!
Or planetary nebula, or an artistic rendition of one in a virtual environment. No, we're here to talk about something that is really, really starting to get on my nerves. And that whole thing is AI images in the science fan groups, or the, well, really, I guess you could just call it the Facebook science community. There has been an absolute inundation of AI-generated nonsense in the science groups on places like Facebook. Others have already talked about AI-generated content on even YouTube for fake science videos. But I wanted to talk about this one because it's something I'm familiar with. This was spread, and it took me 2 days, and I haven't gotten through to people yet. I have been on this for 2 days to explain this is not real. This is an AI-generated rendition of a black hole. It is not even that. And we're going to go over the very reasons why none of this even makes sense. Okay, so why don't we start with the fact you can see it with details. You can see it with details. But if we continue on, which oh dear. There, let's zoom it out a little bit. There we go. Okay, so we're going to start, and we're going to talk about where the accretion disk should be. There's no accretion disk. As you can see, even... Oh, dear. I'm having problems on my end. You're not going to see it. You're just going to see an image on the video. But if we look at the top, which would be the best area to start with the example, let's look at the top. Why can you see clouds? Why are there nebulonic clouds all around this supposed black hole? That doesn't make any sense. Now, we're going to take a look at what this accretion disk should be right at the boundary of the event horizon. You can look at the top. It just looks like someone made, well, why does it look like a crater? Like the shape, the overall shape of this entire thing just looks like a caldera in space. Because the clouds look like they move in an upward-like direction, and then down. And at the bottom, you can still see the accretion disk is still not making any sense. None of it. And on top of that, you look at all the stars around the accretion disk and near the event horizon, and there is no gravitational lensing. This is a fake image. Obviously, it's AI generated, and even the AI didn't even understand what a black hole is. In fact, I am going to take you in this world, in this VR world, I am going to take you to a world that does have a scientifically known, like scientifically what the science community does believe and have a lot of mathematical data to state what a black hole would look like were you to get close enough to one, because we'll go over more details soon. But let's go ahead and go to a black hole. And in this world, it's just called black hole. I know I look very orange, but come with me, okay? Behind us, we're going to go all the way out there so you can... What is going on here? There we go. We're going to go all the way out here, and we're going to go over the details of this black hole. Come on. Just come on. We're going to kind of jump out here, as you can see. So this is what a rendition, or this is an artist's rendition of what a black hole would look like. As you can see, we're just at the edge of this black hole's. In fact, this would be a supermassive black hole. This wouldn't just be a stellar mass black hole. We're right at the edge of its accretion disk, which would literally just be gas and light. In fact, the closer you get to the edge of its accretion disk, all the way near its event horizon, it gets brighter and brighter, because that light's moving at relativistic speeds, or velocities. And the light you see at the top and the bottom, all around it, is all technically also light from behind the black hole. So stars that are emitted... In fact, look up at the top up there. In fact, I'll zoom you in. Do you see how the stars at the very edge are stretched? And it looks like they're curving. And the reason is because the light is bending. That is gravitational lensing. This is what happens around the event horizon of a black hole. Now, you're not going to get all of the light, obviously, because when light falls into a black hole, it will not escape. It is infinite density in an infinitely small area. Really, the event horizon states where light can no longer escape. But what I should reiterate is that while these have a ton of mass, like this one would be a super massive black hole. Look at all that gravitational lensing up here. That's what the image that I showed you does not have. It does not have gravitational lensing. None. It is an image that makes no freaking sense. Anyway, losing my train of thought, because just looking at this awful image it's so bad. It is awful. Awful. In fact, I'm going to use this as my thumbnail. Just awful. Anyway. So, wow, I could be here. I could sit here all day and just stare at that. I'll be completely honest there. I would stare at this all day, because this is what a black hole would look like. But again, in fact, I am going to get rid of this window. I actually have a virtual window up so I can point at the image, but I am going to get rid of it because I do not need it at the moment. I have already pointed out the lack of accretion disk. But a supermassive black hole like this one would be between, what did he say, 100 million, something about, I think he said like 100 million solar masses to billions of solar masses. Being a solar mass is just our standard of saying the mass of our star that our planet orbits. This one right here would probably be To keep it simple, we'll just say it's our supermassive black hole, being Sagittarius A star. I'm not saying it is, but we're going to be simple. Is, what was it, 300 million masses? I'll double check because I think I'm wrong. The only type of black hole that we have not confirmed yet is the... Oh, I'm sorry. I thought I was moving. Is the intermediate mass black holes. We haven't actually confirmed those, but there is one they think we have confirmed. And that would be, I think they said it was in the constellation Cygnus, is 800 solar masses. So if it is a black hole over there at 800 solar masses, the diameter of that black hole is half the diameter of our moon. So it is very, very tiny. That's the diameter of its event horizon is what I'm trying to get at. And we only have we only have 2 images of black holes. Only 2. And that would be M87, which was taken in 2017, and the other is Sagittarius A, being our galaxy's supermassive black hole. And we did not do that with optical telescopes like the AI-generated image would have you think. No, they were done with a planet-wide array of synchronized radio telescopes. And the reason why they used so many telescopes all over the planet was to increase the, I guess you could say, the radial lens of how much they could cover, making the entire lens the size of our planet. That's what it took, and it took 7 days of imaging. And M87 took 7 days to image because it was the only galaxy that we could find with a large enough supermassive black hole face on. But it took 7 days and nearly 5 petabytes of data. 5 petabytes. So they said it was nearly half a ton in hard drives alone to hold and compile all the data necessary to get this one image. And when I'm pointing up right now, I'm not pointing at the artist rendition. I am pointing at M87. It took 7 days, nearly 5 petabytes of data. And it is a golden image. That is an actual black hole. But it was done in radio frequency because the size of that actual image in space is absolutely tiny and really, really far away. While Sagittarius A star is obviously much closer. Sagittarius A is also a smaller supermassive black hole, and we have to navigate through, well, everything in our galaxy that is in between us and Sagittarius A. Which would be, well, the entire galactic disk minus the opposite side of it. That is a lot of work. And it's very difficult, and it's still absolutely tiny. In fact, I believe what did they say? That the event horizon of Sagittarius A, if I remember, is barely over 1 astronomical unit. Because obviously we're talking 300 million solar masses. So the event horizon could, I think they did say, was 1 astronomical unit, which is only the distance between our star, being the sun, and Earth. That's really, really small in galactic terms. That is tiny. So we got an image that's 1 AU. What was it? 39,000 or so light years away is how, I think that's about how far. I'll do a double check because I can't remember off the top of my head, and most of what I'm talking about is off the top of my head on what I already know without having to look it up. But needless to say, I hate this AI image with a passion. I do not like People sharing around AI-generated images and saying, wow, it's so incredible, look what... And they keep trying to say it was the James Webb Space Telescope that took the image. No, it's not, because this is visual light. This is trying to look like visual light spectrum. Guess what James Webb Telescope does not have? Visual light spectrum. It only has near-infrared spectrum. And any black hole that tries to image, it's not gonna work. Black holes are too small and too far away. I believe the closest one that we found so far is 3,600 light years away, and it's a stellar mass black hole, absolutely tiny. We are not going to be able to even get a radio image of it because it is too small. Please, if you like to be part of science groups on places like Facebook, X, YouTube, Discord, anywhere, if you see people sharing images like this black hole, please, if they genuinely believe what they're seeing, feel free to educate them. In fact, what I had to do for 48 hours, by the way, is constantly link people to at least Professor David Butler's How Fast Is It video on black holes. It's a very good piece of material to educate people. So if you have to, let them watch that, because it will go past his videos of general relativity, but it is highly informative of just how mind-boggling black holes are. And he also goes on the details of how the real images were taken. And again, I'm going to reiterate, this is what a mathematical artist's rendition of a black hole would look like if you got close enough. You wouldn't want to actually be this close to the accretion disk of a black hole, because that gas down there, which is also mostly photons, by the way, that stuff's really, really hot. Not to mention, you start getting over there, you're going to start worrying about spaghettification, especially at the event horizon. You will spaghettify and die. The interesting thing, though, is the closer any physical piece of matter that is visible, the closer it gets to a black hole, because it's reaching relativistic speeds, eventually will look like it just stops. Like it just stops moving and may eventually just fade away. It will look like it'll constantly slow down the closer it gets to a black hole's event horizon. Oddly enough, I think there's an object in here. Well, a toy, whatever thing. Is this it? Yes, this is it. And we might be able to fly ourselves into said black hole. This is all artist renditions. In fact, this part is all about fun, really. So let's, shall we? See if it lets us. Yep. I'm gonna respawn after this one, but we've completely left. So it's as if we're passing the accretion disk, and really for us, in fact, if you look up here, light bends more and more and more, and we're technically in. This is all the stuff what you saw there briefly is what we actually don't know about black holes, because we don't have that kind of technology. Period. We do not have that technology. We barely have the technology to image Sagittarius A and M87. And that was, again, only in the radio spectrum. You know what? It's too dark here. I'm going to do this one. It's brighter. Hello, you can see me again. I'm going to turn the volume down in here for a little bit. There we go. But there you go. If you see people sharing images like this, and they genuinely believe it's real, because my second father, who is actually my best friend Crescendo's father, and he's like my father as well, he believed it was real. He thought it was James Webb Telescope, and I had to go over the length of explaining to him, because I try to take things from an honest point of view and a chance to inform or enlighten people on, well, you can tell I really like outer space. I love astrophysics. It's amazing stuff. So I took the time. What really bothers me, though, is when people do it maliciously, hoping that people will believe it's real, because it gives science a bad name. People who use science for ill purposes, like deceit and control. That is a whole other topic we needn't go over right now. But I don't like that kind of stuff. I really don't. I want people to just enjoy learning things that are based in reality. I understand that this is science that we can, most of it we can barely observe because of, well, distance. We're really far away from these objects. The furthest any human has ever gotten is the moon. What is that? 230,000. What the fuck happened? There we go. The furthest humans have ever gotten so far is the moon. That's about, what was it, 243,000 miles from the surface of Earth? That's the furthest we've gotten. We haven't made it to Mars yet. That's millions of miles. In fact, it's Mars is 1.5 astronomical units from the sun. So it's another half astronomical unit from us to Mars. That's pretty big. That is a really, really long way to go. The furthest any human object has ever gotten so far is, I believe it's one light day. In fact, I don't even know if it's a light day. I think it's, I'll double check. It's either one light hour or one light day. And that would be Voyager 1 and 2. Man, my eyes keep doing some weird things. But Voyager 1 and 2 only just barely started passing through the heliosheath and heliopause of our solar boundaries, which are way out in the Kuiper Belt, or just past the Kuiper Belt. There's no way those things are going to stay alive long enough to even reach the Oort cloud, which is 1 light year. They're not going to last that long. Because, like I said, it's either 1 light hour or 1 light day. In fact, they're not. I don't even think they're to a light day yet. Which is the distance light can travel in a single day in a non-gravitationally influenced vacuum. I also had to explain to someone that sound does not travel in a vacuum. Because they were trying to think that black holes would be formed from sound. Sound. No. Gravity. The way black holes are formed is not from sound. Sound does not travel in space. Waves don't travel well in a vacuum. The only physical wave, like one that can be, I guess, interacted with without, visual, like light spectrum, is gravity waves. Those are the only type of wavelengths that we've detected outside of light spectrums. Because I say light spectrums because X-ray, gamma ray, light, and infrared are all light waves. But gravity waves are not a light wave. That's the only other wave we've detected in space, as far as I know. I'm not 100% on it, but I do remember them talking about gravity waves. I know for a fact sound waves do not travel in space. There aren't enough. I'm not going to say there are no molecules, because I do know there are atoms in space. There just aren't enough to actually interact with and use to keep passing a wave. So like when I tried to explain that, this person's ignorance was, then how come I can hear you talk? I was like, dude, we're breathing right now. We're in the atmosphere, which is it's actually dense. We have a dense enough atmosphere to support breathing. Ain't it great? I love breathing. I like being alive. The fact the air is enough where you can wave your hand and feel it pass through your fingers is enough for you to breathe and hear. You go out in outer space, you're not going to hear it. Anyway, I've ranted enough, and I I'm going to double check and make sure that this has been recording because my computer has been a little funky with my controllers trying to actually control the second monitor. It's been weird. Hang on. I'm not facing the computer. It's over here. Let me take a look over. Oh, no. Please tell me you're running. Hooray. Wow, this has been a long one. Whew. Okay, this video's been longer than I expected. I was a lot more upset than I initially... Well, actually, I know I was upset as I thought I was. I really, really do not like that AI black hole image. I hate it. I'm not going to drink over it, though. That ain't worth it. Just remember, the reason I do these videos is purely to keep myself on track of making it to day 365 sober. And then decide what I do from there. Right now, this is day 60. I have a relative who's excited for 9 days from now. If you know what I mean. Anyway, I'm staying strong on that. I've had my fill of explaining black holes as best I can without a script. Because I'm not very good at speeches. I usually talk off the cuff anyway. I thought about writing a script, but it's been a day. Because like I said, I explained it to my second father, which I enjoyed doing. I enjoyed having that discussion because at least he's reasonable. The other people on the actual fan page, which is literally the fan pages for Professor Neil deGrasse Tyson. You know, one of the greatest TV voices America has for astrophysics. A fan page for him filled with flat earthers, hoaxers, and idiocy. Just sheer idiocy. I seldom ever see anything of scientific intelligence. It's quite bad. Anyway, I've rambled enough, so I apologize. I'm going to get out of your hair. This day 60 is good. It's good. I'm happy to be here. I hope you've enjoyed this little, I can't say it's a soiree. There's no dancing here. And I'm not dancing. I don't feel like breaking my hip again. This is Terra Quator, day 60 on the leap day of February 29th. February 29th. Yeah. Day 60. I'm sober. I'm feeling great. I will see everyone tomorrow on March 1st. Being day 61. See you around. Enjoy the view.